Okay, okay. I think that's fine. Is that window fine? I think that's Windows fine. Okay. Hopefully the window's fine. You have no idea what I'm talking about, don't worry about it. Anyways, welcome back to Silicon Dojo, authorities, gatekeepers, free to use your hands-on technology education that empowers you to do whatever the hell it is that you want to do. Today we're going to be having a class on Raspberry Pi and what exactly this thing is. Basically, it's a full-fledged computer that gives you a lot of additional functionality because it has something called GPIO Pins that allows you to do cool things like, well, it's not blinking anymore. But anyways, it allows you to make LEDs blink. And it allows you to control for an LCD screen. And so the idea here, which is kind of interesting, is you could have like an AI system on your little computer running through some fancy AI algorithms, but then the output, you don't necessarily need a 4K screen, you just need to know when it's done or when something happens. And so you can have very fancy algorithms running on your little Raspberry Pi and then just output some kind of notification to you on what's going on. Again, we've done things like network testing stuff in the past, and with that normally we output to a screen, right? So you got this big ass monitor and it is what it is. So basically you just got a big monitor and you got like a web interface up there. Well, think about it. What if you could just have an LED? What if you just have, 4 LEDs? If a website is reachable, the LED is green. If the website is not reachable, the LED is red. Wouldn't an LED actually be a much more effective user interface than a 4K screen? And again, this is one of the things I really want folks to be thinking about. Again, my students, this is the kind of thing that I want you to be thinking about, is why are you deploying what you're deploying? Why are you using what you're using? Right? Is it the most effective thing for what you're trying to accomplish, right? You could go out and buy a $10,000 8K screen in order to output information, and that might actually be a pretty not valuable way to your users to output information, whereas simply having an LED turn on or off, that might actually be a hell of a lot more effective. And so that's what I want you folks to be thinking about. And again, with the Raspberry Pi, they have these things called GPIO pins that allow you to do all that kind of stuff. Oops, more people do it. No, not that one. Too many computers. I have so many computers on my desk. Anyways, okay, so again, this is Silicon Dojo, blah, blah. So we have our website. This is our hub for all of our activities, silicondojo.com. It is only going to become more of a hub as we go forward. We are using Wix as the back end for this thing, and I do have to say, Wix is amazing. It's amazing. There's a lot of functionality. So we have a membership component, we have a forum component, basically we have an event component that we're already using. There's e-classes that are coming up. So these are these classes that are simply recorded, but I'm actually going to have a whole curriculum just on self-paced classes. That's going to be here. And then I'm also going to be working on office hours. So for the folks out there, if you have questions and you want a one-on-one deal, at some point we're going to have office hours up here, so you can schedule like a half an hour time slot to say, hey, I need some information about X, Y, or Z, and we can talk. And basically, this is going to be the hub for all of that. Again, Silicon Dojo is free to the end user, not actually free. And there's a little donor box link that is right here. If you click on that, you will see a link where you can throw me some money. $1, $2, $5, $100. A month would be lovely. But anyways, that exists if you want to throw some money in. So all these classes, I am recording in 4K. So you're watching it on Zoom with a really horrible resolution. I do have a 4K camera right beside this. That does go get recorded, edited, uploaded to YouTube, and it should be on YouTube either tonight or generally tomorrow, just so you know. We do have the GitHub account. So the GitHub account, this has all of our information, all of our documentation. You can take this and you can use it as you see fit. And if you want to follow me on LinkedIn, this is the only social media I really use, so you can go and follow me on LinkedIn and see what I'm talking about there. And yeah, that's about all we got for the intro. I will say, if you have a question, do make sure to raise your hand inside Zoom. There, raise your hand, and I will answer your question just as soon as I have a moment to answer the question. So anyways, There you go. So we're getting into our class. The goal today is simply for you to learn the basics about Raspberry Pis. Raspberry Pis, like much in technology, is incredibly simple once you understand what the hell is going on. Again, that's one of the things I try to do with these classes, is try to give you a foundation of what the hell's going on so that you know how to Google for whatever it is that you're trying to accomplish. Raspberry Pis are relatively easy. It's just when you first start taking a look at them, you don't know what the hell you're looking at, right? You're sitting there and you're like, should I use a Raspberry Pi or should I use an Arduino, right? They're the same thing, aren't they? And that's what I thought like 3 years ago. I was like, I wonder if I should do Arduino or Raspberry Pi. And here's the thing, these are not the same thing. These are not the same thing. That's like saying a Hummer is the same as an e-scooter. I mean, both things will get you from point A to point B, maybe, but they are not the same critters. Again, so when you're thinking about Arduinos or Raspberry Pis, you do have to understand they are incredibly different. It's comparing oranges to tanks. It just doesn't make a damn bit of sense. When you're dealing with a Raspberry Pi, you're dealing with a full-fledged computer. Love it. Or, and there are many reasons to hate it, you're dealing with a full-fledged computer. This has an operating system. You're going to be running essentially Debian Linux OS on this. You're going to be configuring server services. You deal with TCP ports. You deal with permissions. Basically all the stuff that we learned in Linux, that's what you're going to be dealing with on here, right? You can actually run VS Code directly on here. You run Python scripts in order to communicate with these things called GPIO pins. And basically, it is simply a low-cost computer that happens to use an ARM processor and has some additional functionality over what you would consider a normal desktop computer. When you look at this is damn near none of those things. They're not the same. An Arduino is something called a microcontroller. Basically what happens with a microcontroller is you create this code using the Arduino IDE, and basically all it does is it just does a while true loop forever and ever and ever, amen. You don't write in Python for it, you write in a derivative of C within the Arduino IDE, you create your configurations, you set all of your environment variables, you set the startup variables, and then you literally create a while true loop. Essentially it's a while true loop that just loops, right? And so basically it's looking for inputs from the outside world based off of the value of the inputs, then that triggers events to happen, and that's it. This is a computer. This is a microcontroller. These are very useful, but it's just not the same critter. Again, we're talking about Raspberry Pis. There's lots of different Raspberry Pis out there. So this is a Raspberry Pi 4. It's what I'm going to be shoving in your face today because my Raspberry Pi 5 is down there and it's all plugged in. This is called a Raspberry Pi Zero. So again, this is a full-fledged computer. I do believe it has a quad-core processor on there. It has 512 megs of RAM. You know what's funny? Back when I got my MCSE back in 2000, I do believe this is more powerful than the servers we used for running our enterprise. But anyways, this also has a full operating system, and this is also from the Raspberry Pi Foundation. It is called the Pico, and it is not a full-fledged computer. This is a competitor to this. So do be careful, because some people are like, wow, I don't know. Spending $15 on a computer, that seems a little expensive. I'm going to go out and I'm going to buy Raspberry Pi's $5 computer. Again, understand, this is a microcontroller, this is a computer. They are not the same thing. Again, they have their own values and all that kind of stuff, but they are different. Let's see here. The versions. So we'll talk about the versions a little bit because this is an important thing. So this is a Raspberry Pi 4B, and you can see about the size of it. This is a Raspberry Pi Zero, and again, you can see the size of it. Again, this is one of the things I talk about, like whenever I do commentary videos, and I tell people to be careful. I'm like, hey, people. Be careful about modern warfare. I just want you to understand something. I want you to understand, like when you see what's going on in other places in the world, I don't want to name any names, and why I get a little concerned is, so this is a full-fledged computer. It's a quad-core computer with 512 megs of RAM, and this is actually the older version. The new version is like 3 times faster than this, and this is a full-fledged GPS unit. This is actually a full-fledged GPS unit. And so you connect these together. This costs you $15. This costs you like $25. That's about $4. That's about $4 for basically a full-fledged navigation package for whatever device you want going from point A to point B. And again, you code in Python and do all kinds of other fancy stuff. So, this is why you should be concerned about the future of warfare. Anyways, there's these different versions. If we go, sorry, the mouse is there, we can take a look at it. So the 5B, what I just showed, or the 4B, I'm sorry, the 4B is what I just showed you. So they do start for these, they do start at about $35. Now, one of the things to be thinking about when you buy these is, if you're going to be buying a Raspberry Pi for your lab, right? You're buying a Raspberry Pi for your lab, buy a Raspberry Pi 5. Right? It uses GPIO pins, it's the PiOS, the whole 9 yards. It's going to cost you some more money. I think it's going to cost you like 65, 80 bucks. But the nice part about that is that's going to be the most power you're going to get, right? It's 3 times faster than the 4. It's God knows how much faster than this thing. Got all kinds of fancy cool stuff on it, right? So if you're going to buy a lab computer, buy a 5. But then once you have your lab computer, so you can do all your testing and playing around, the next thing you need to be thinking about is what is the resource utilization for whatever project you're using that you plan to put out into the field. Because again, this costs $15, this costs $35 or more, Pi costs $55, $65 or more. So one of the things you want to be thinking about is what do you actually need? Do you need the power of a 5, or will a 0 do fine for you? And again, this is where we go into that whole architecture thing. This is something that you need to be considering. Let somebody in. So we take a look at the 4. Again, it starts at $35. You get the 1 gig version, the 2 gig version, the 4 gig version, or the 8 gig version of RAM. So when you're taking a look at this thing, basically the RAM is soldered onto it, just like Apple does. But again, their computers are less than the cost of a stick of RAM, so who the hell cares? You have the RAM that's soldered on. You have the processor that's soldered on. You will have your USB-C, so you have a USB-C connector. This is for your power supply. This is not for anything else involved with the USB-C world. You will then have 2 HDMI micro ports that come out that are supposedly able to display at 4K. Now again, once you start dealing with the Raspberry Pi world, remember, you're buying $35 computers. Does it display at 4K? 2 monitors at 4K, yes. Are you going to be playing Crysis on it? Probably not. But anyways, those 2 are there. You have a slot for display, so you can actually connect a display directly from the board at this connector here. And you have a camera connector. So I meant to grab my cameras. I forgot to grab cameras. Anyways, you have cameras. And basically you have these little ribbon cables that you can plug directly into the board for you to be able to connect, obviously, a camera to the board. You have USB 2, so again, in the modern world, I don't understand what this is, where you have both USB 2 and USB 3. So USB 3 is fast. If you need to move data around, plug into USB 3. USB 2 sucks. Don't move data on USB 2. So the only thing to be thinking about this is plug your keyboard and mouse into the USB 2, and then you leave your USB 3 open. It then does have a gigabit Ethernet port if you want it, and it also does have an audio connection if you're going to do music or something out of it. Let's see here. When you come down and take a look at the specifications, or you go over and take a look at the specifications, we can take a look at it again. So this has a quad-core 1.8 gigahertz processor on that thing. 1, 2, 4, or 8 gigs of DDR4 RAM. It has 802.11 AC wireless, so it actually has good wireless on it. It has Bluetooth 5.0. This is going to be a big thing when you're making IoT devices. Bluetooth may be how you're communicating with the device, so understanding what version of Bluetooth is on your device is good. Gigabit Ethernet, and a whole bunch of other stuff here. Now, one of the big things with the Raspberry Pi 4 is it will run off of a 5-volt power supply. So when you buy this thing, when you buy it, all you're going to get is this board. And the board has a lot on it, right? It has the RAM and all that kind of stuff. You're going to need to have a micro SD card. So the micro SD card slots in. So that is what your storage is going to be. So you're not using IDE, you're not using SATA, you're using literally an SD card, which can be good or bad. You're going to need that, and you're going to need a power supply. So they have, where are they? Oops. I'm using that. Anyways, there's a little block, little 5-volt power supply, and so you want to make sure that you also buy that when you're buying these things. So again, this is basically all you're going to be getting with the Raspberry Pi 4. We go over and take a look at the Raspberry Pi 5. You start to see something that is a little bit more powerful here. So basically the same type of thing going on with the board. Let me go, let's take a look at tech specs. Did I give you a picture of the board? Where's a picture of the board? And of course they don't give you a picture. Well, I guess we can do that picture. Oops. Anyways, so if we take a look at the board, so it is slightly different. Now, one of the things, whenever you're going to be buying either the 4 or the 5, one of the pains in the asses is this looks very similar. The 5 and the 4 look like they have the same form factor. And if you're not paying attention and you just start buying stuff, you're going to waste your money. They are actually not the same form factor. So the network port is swapped over to the other side, and there's some other differences between the 4 and the 5. Why that's going to matter is when you go out to do things like buy cases, right? Or if you're going to buy screens that you can actually connect a board directly to, they will be designed for a specific form factor. And so if you buy a 5 and then you buy accessories designed for a 4, they're not going to fit together very well. So do realize that they are different form factors. One of the cool things with the Raspberry Pi 5s is they actually come with a PCIe bus. So PCIe, this is what you can use to actually run graphics cards. If you watch the YouTube channel Jeff Geerling, he does a lot of tests with Raspberry Pi, doing a lot of weird stuff with it. And so one of the cool things here is you actually now have the ability to use a PCIe bus to connect into graphics cards in order to connect into a storage array, that type of deal. Though, what you can technically do and how quirky it is in the real world might be a little bit different story. Beyond that, they then have the slots down here. These are for either cameras or display. So one of the cool things with the Raspberry Pi 5s is you can put in 2 webcams if you're going to have a robot, so you have that directly connected to the device, or you could put in 2 screens that are also directly connected to the device. And so that's kind of an interesting thing. Again, when we talk about IoT, we talk about robots and that kind of thing. It does come with a power button. So one of the things that's weird with this is it has no power button. The only way to power it on and off is literally unplug it and plug it back in. One of the cool things with the Raspberry Pi is it actually does come with a power button and has a connector for PoE, Power over Ethernet here, for something called a Power over Ethernet hat. If you want it. So that's basically how this thing looks. If we go and take a look again at this text specs, so it's got a 2.24 gigahertz quad-core processor with cache and all that, with cryptography extensions and 512 kilobytes of per-core L2 cache and the whole 9 yards. It actually has a video core GPU on it. I mean, you know, it's a GPU. They soldered a potato and called it a GPU. But, I mean, again, it's better for graphics processing, so that's actually on it. Dual 4K, 60 frame per second HDMI output. Again, how well that's going to work for you, meh, right? It actually has a decoder for video that is built into it. They have 2 gig versions, 4 gig versions, and 8 gig versions. I do understand that they're supposed to come out with a 16 gig version of this thing later, but who the hell knows? It does have 802.11 AC, 5.0 Bluetooth, and a whole bunch of this other stuff down here. Again, to give you an idea of what's going on. Now, one of the big things is if you have 4s, so it's 5 volts. So the 4s use a 15 watt power supply. The 5s use a 27 watt power supply. So one of the interesting things with the 5 and the 4 is you can make a 5 run off of a 4's power supply. I'm actually doing that today. Because when I bought my 5 and then it started collecting dust for a while. Anyways, when I bought my 5, they were literally out of stock of the 5 power supplies. But the cool part is you can actually run it off of a 4 power supply. The thing is, it doesn't necessarily have enough power to be able to power all of the accessories that you might connect to the Raspberry Pi 5. So that's one of those things just to kind of keep in mind. Now, one of the cool things with it too, and again, again, what makes me excited? I know a lot of you. Don't think I get excited about things. I don't give a damn. Blockchain, I don't care about. VR, could care less. AI, I am so snarky about AI. But let me tell you, you know what I get really excited about? You know what made Raspberry Pi 5, boys and girls, it's got a real-time clock. You do not know the pain of not having a way to measure time until you're using a Raspberry Pi 4. So one of the weird, again, quirks of the technology world. Like there's all this stuff you're just used to. Like clocks, right? Computers have clocks, don't they? Well, Raspberry Pi 4 doesn't. So what the real-time clock is, it's a very simple thing. It's been on every normal computer for 40 years now. But basically, you just have a little, BIOS, right? If you've heard of BIOS, right? You got this little thing called BIOS, and it is something called a real-time clock. And you normally have like a watch battery. There's a little watch battery connected to like a laptop computer or a desktop computer. And basically all that does is it keeps the clock moving even when the power is pulled out. Right, so you pull the power on a computer, you put it on the shelf for a month or two, you plug it back in, and the time is still correct. Yay! Right, well the thing is with the Raspberry Pi 4, it does not have a real-time clock. So you unplug it, and it goes back to whatever the initial time was. Now it can do a network update for the time, but that takes a little bit of time to happen. Now why this is important, right? Especially if you've got a database, if you're doing logs of any kind and you've got a database, one of the things that you're going to want to have in your database is things like timestamps, right? Event happened at timestamp, event happened at timestamp, event happened at timestamp. You don't think about it. You don't think about it, right? You just write your code. Of course you have a decent timestamp. Yeah, but the thing is, this thing resets itself until it updates its time, if it's able to update its time. So if you have a database that's pulling in values for a log file, and then every time this thing gets rebooted, the timestamp goes back to God knows what, that can be an abject misery, depending on what you're doing. One of the great things about the Raspberry Pi 4 is it actually has a real-time clock built in. So that means you got time. You got so much time. Now one of the things with this is it's kind of weird. There's a little port on it. I don't know if we go up and take a look at it. There's a little port on it, and in order to make the real-time clock work, there's like this real-time clock battery. You have to buy it. It costs like an extra $5. Of course it does. And there's this little battery attachment you have to connect it to too. So the Raspberry Pi 5 does have a real-time clock. You just have to buy that additional accessory battery to make sure that it's working. And it is just so like, oh... You can keep your AI. You can keep your AI. Give me a real-time clock and I'm a happy boy. So we go down and we talk about the zeros. So the zeros are these things. These are the small ones. Right? And they're teeny tiny. Right? If we go and we take a look at it, well, let's see if we can see the tech specs of this thing. Oh, they don't like their pictures. Anyways, okay, I'll scroll back up to take a look at the picture of it. Okay, so this is basically what the zero looks like when you blow it up. So one of the weird things here, again, something to be careful about when you're buying accessories. So this uses a mini HDMI connector. Now, so these 4s and 5s use micro HDMI connectors. Zeros use mini HDMI connectors. Don't ask me why, that's just how it works, right? So it's got the mini HDMI connector here. This is where your SD card goes. And then it has these little micro USB ports that will also make you lose your damn mind. So when you take a look at it, right? One of them says USB, one of them says power in. So this one right here is only for power. So you plug the power into this, and that's all you got. If you plug a keyboard into it, or a mouse into it, or anything else into it, who the hell cares? Because it's not going to work. All this is for power. You get this one USB connection right here. which can be oh so fun the first time you're trying to set this up. So what you need, basically, is you need a USB splitter thing. So when you're initially building these, like, so if you just image a whole bunch of SD cards, slot them into these things and ship them out, they're fine. But when you want to do configurations, when you want to actually administer this thing, basically this has a micro connector, USB connector at the top, and then essentially it's a little hub that splits out to 4 A's, and this is another micro there. So that way you can plug in your keyboard and your mouse and anything else if you need it. So do be careful with that. If you buy the zeros, they are great. This will make you lose your mind. Up here, it also does have a camera connection. It does not have a display connection. It does have a camera connection, but again, things to keep in mind. You know, it's funny with people that are in the tech world, they think all of tech is like TCP/IP and like coding, and so much of what we do is learning what product to buy. What goes into you feel like a 6-year-old every once in a while. We're like, why doesn't the circle go into the star hole? I bought the circle to go into the star hole. And then you got to find a star to go in the star hole. So anyways, the weird thing with the zeros is, so this is a ribbon cable. This is the ribbon cable for a camera, for a Raspberry Pi 4 or 5 to connect, right? So on this side, where the camera goes, oops, hold on one second, let me grab a camera for you. So you get an idea of what these cameras look like. So this is a camera, plugged into I have it glued to a Lego block. Anyways, so right, you got the cable coming out of the camera, right? So with this, it's a normal size, and so this would plug into a 4 or 5. For whatever reason, don't ask me why, they put a mini camera connector onto the Zero. So if you take a look at it, you need to get a special ribbon cable where it's small on the top and big on the bottom, and that's what you would plug into a Zero. I don't know why. They just did it that way. So again, some of the quirks when you're dealing with this stuff. Yes, that's the thing. Like when you start dealing with Raspberry Pi, like give yourself a budget and then add like 25% for the additional crap that you're going to need to buy. Anyways, then we go down and we take a look at the tech specs for it. Again, it's really pretty impressive. So this is for the new. So they have this, the Zero 2. This is the 2nd generation of Zero. So think about this. Literally on something this size, 1 gigahertz quad-core processor, 512 megs of RAM, 802.11b, G, and N for wireless. Do keep that in mind, especially if this is an IoT device. N is significantly worse than AC. AC is amazing. Again, when you go from wireless, like B was crap, G was finally worked. N was, oh, this isn't too bad. AC is, yes, this is what wireless is supposed to be. And then AX is just extra stuff on top of that, right? But anyways, one of the things to be thinking about though is these do only have N wireless on here. So depending on what you're doing, that might be a bottleneck or it might be an issue for you. Mini HDMI port and micro USB on the go port, micro SD, camera connector, all those kinds of different things. It even has a little MPEG-4 decoder on it. I mean, it does. Again, this is the kind of stuff that makes me giggle. Like you see tech specs, you're like, really? Really? I mean, I guess. You could probably use this for like a kiosk. Like maybe, if you were trying to run a digital display, so let's say a 1080p digital display, and this was just picking up and putting it onto a screen, I might have it do that. I mean, you're not watching YouTube videos. I'm not even sure you'd be watching, motion JPEG or whatever. But anyways, they've got that kind of stuff on there. Now, one of the things you'll see with this that I have in my hand is this is something called headerless, and this is something called with header. So basically the idea here is, again, depending on what your project is, if you're going to be putting this into a production environment, so you know exactly what GPIO pins to connect to, you may want to solder directly to the board in order to keep a nice, tight, smaller form factor, right? Or if this is just a computer device, you don't actually need the GPIO pins, and so when you buy it like this, you get it obviously without the GPIO pins. You can buy a set of GPIO pins and solder them, you know, if you want to be Louis Rossmann. I do not want to be Louis Rossmann, so when you go out and buy these, you can buy them with headers pre-soldered. It's going to cost you $3, and it will be the best $3 you've ever spent in your life. Again, it's one of those things everybody always wants to like save money. They're like, oh, I'm always trying to save money. I don't want to spend any additional money that I don't have to. And again, you look at this, and it's like, do you really want, is $3 worth soldering headers onto? But anyways, so they have headerless and with headers. With you guys, I would argue, buy with headers. Let's see here. Yeah, and if you go to Adafruit, again, Adafruit is a great company. So if you're going to be buying Arduino stuff, Raspberry Pi stuff, any of this kind of IoT thing, Adafruit is just absolutely fabulous. Go to Adafruit. So as we can see here, so without header, so again, we'll go without header like that. That is going to cost you $15. And pre-soldered header is going to cost you $3 additional. Spend the money. Be a real baller. Be a baller. Like, yeah, I always buy my headers pre-soldered. Then we come to the compute module, which is actually pretty cool, and we don't really use it all. And basically what the compute module is it's the idea of what if the compute was actually a replaceable item like on your IoT device. So imagine you had some kind of IoT server. And when I say IoT, it's called Internet of Things. Basically, you put compute into everything essentially. So let's say you have a NAS, right? So you have a NAS, a network attached storage device. Let's say it's doing some proxy stuff for you. Let's say it's doing some cache stuff for you. Now the thing is, like your drives are going to be good forever at this point. Drives are good enough. The backplane or whatever for the drives, they're probably going to be good forever too. But one of the things is, as time goes by, you might want a little bit better computer. Right, you know, a bit more better RAM, a bit better actual processor, that type of thing. And so what's really cool about the compute module is basically what this is designed to do is it is designed to be a module that you can simply plug into a device, and then if it burns out, you need to replace it, or if you need to upgrade, you simply pluck it out and shove a new one in. So you're like, oh, I wish my NAS had 16 gigs of RAM and had a better processor instead of the one it currently has. You literally crack the thing open, yank the old thing, shove the new thing in, and away you go. Compute modules are really, really, really cool. They've got a lot of functionality here. Now the thing with a compute module though, is again, if you take a look at this, the only connector you're going to get is this connector that's going to be on the bottom, and then that is going to connect into boards. Do they give me any boards here? Anyways, they don't give me any boards. So that will connect into what's called a carrier board, and that carrier board would then have all the additional hardware functionality. Again, if you're going to be making, let's say, some kind of intelligent networking device, you might plug this into a board that has a whole bunch of networking ports on it, like 16 networking ports, and this is going to be the compute module to decide how traffic gets routed, that type of thing. So compute modules are great, they're awesome, but we're not going to talk about them a lot. Again, then we have the Pico. Pico, as I talked about before, is not a computer. It is not a $5 computer. It is a microcontroller. So again, basically with this, all it does is essentially goes through a loop. The cool thing about the Pico is you can actually use MicroPython. So there's a version of Python that's built for running microcontrollers. So if you already know Python, MicroPython should be a little bit better for you, but basically this is what a Pico is. Let's see. There are other variations of the Raspberry Pi. Pi has been around for a while now. So I think there's 1s, and there's 2s, and there's 3s. So you can go and you can take a look at them. Again, they've got different hardware specifications, that type of thing. I don't know. I would say the 0, the 4, and the 5 are generally going to be the standards that you're going to be dealing with. When you buy the Raspberry Pi, again, all you're going to get when you get the Raspberry Pi is the Raspberry Pi itself. Oops, I have to get something. Hold on. I've got a cool example. cool example thing for you. Anyways, so when you buy the Raspberry Pi, there you go, all you're going to get is the Raspberry Pi itself, and then you get to plug in a whole bunch of different accessories to make it work. Everything from computer screens, so you know, computer screen, this is actually a touch screen that you can buy, tiny computer screens, I'll show you in a second, LCD screens, keyboards, cameras. And there's like 50 different cameras out there, all kinds of stuff that's available. And the cool thing is, I do want to show you this. So again, we talk about like IoT, and you wonder like why IoT is valuable. So this has a Raspberry Pi 4 in it, and this is actually like a 480 by 320 screen. And so I can actually power this thing literally just off of a battery pack. So, come on. There we go. So I plug this thing in. Come on, work for me. Work for your supper. There we go. So I plug this thing in. See, you can see the screen. That's going to go through, and you actually see that? It's actually showing the Linux login and all that kind of thing. Hopefully that has enough power to get through. If you don't give enough power, it just goes into a reboot cycle. That would be annoying. And then, come on. Give me what I want. There we go. See, look at this. So this is actually just powered off a battery. Look. So whatever. And this is the screen, right? And this is actually a touch screen. Oops. So I guess that's upside down. So this is a touch screen. It's kind of a tall, small touch screen. So if I touch, boop. See, look at that. Then I can touch. And see, these are the kind of accessory things that you can get to make Raspberry Pis a lot cooler. And again, and this is where I talk about, like, you can have a lot of processing going on. You could have like a server doing something really cool. And then one of the questions for you to be thinking about as a professional is, what is the UI that makes the most sense for whatever project it is that you're doing? Again, even if you want a display, so again, like with the network monitoring project that I've talked about before, even if you want a normal display, you want to use Chrome or whatever to display specific information. Again, one of the questions is do you want, you know, a 65-inch 4K screen, or is a little 5-inch 480p screen actually something that's going to be useful for you? So this is kind of one of the accessories that you can get with this. And again, there is just a tremendous number of accessories that are out there. One of the big things to be thinking about, though, when you do get the accessories is things like form factor. And basically what the form factor is the size. So when you talk about form factor, it's the size, it's where the screw holes are placed, it's all of those kinds of things. And so again, a Raspberry Pi 5 will not fit into the form factor, or things designed for a form factor of 4. And so that's one of the things that you have to consider, especially as we go into the future. One of the big questions is first party versus third party components. So when we talk about first party, that's components that are actually manufactured by Raspberry Pi versus third party, all the stuff that's manufactured essentially by China. And one of the things that I'll tell you is, for the most part, the third party hardware is good. Or, I mean, it's good enough. It's good enough to go and take a look at the reviews and see how the reviews are. With some things, I talk about this with Arduino, right? So Arduino, right? If you're going to buy an Arduino, buy an Arduino. Buy the Arduino from Italy. Do not buy knockoff Arduinos unless you know exactly what the hell you're doing. They'll cost you 25 bucks instead of the knockoff for $5 from China, but you know exactly what you're getting. One of the interesting things with Raspberry Pi is the one to manufacture these. So if you buy a Raspberry Pi, you're buying a Raspberry Pi. So this is open source hardware. Arduino is open source hardware. It means it's not a knockoff. It's not a rip-off when you buy one of the Chinese versions. They literally just took the open source hardware specs and built their own. The problem is when they build their own, you know, they shove in whatever components they happen to have in stock at the time, which again, if you know what the hell you're doing, might be fine. But if you're new, it can be really disconcerting when you're trying to figure out how to make something work and it has different components than you're expecting. With Raspberry Pi, the boards themselves are manufactured by Raspberry Pi, so they should all be the same standard. The additional stuff, right, the components that you're going to be connecting to them, that is most likely going to be stuff from whatever Chinese manufacturer. And generally they're good. Generally haven't had, again, as long as you read the reviews, you should be fine. One of the things I will say with a third party, with these kind of components though, is do make sure there's enough stock for whatever your project is. So again, if you're just doing labs, you buy one or two, who the hell cares? They go out of business, it doesn't matter. I will tell you with some of this stuff, because some of it is like very, very specific. Like they'll come up with a really cool like little niche component, and then they'll stop manufacturing the damn thing, and you have no idea how to get your hands on any more of them. So again, if you're thinking about deploying 100, 1,000, multi-thousands of these things, make sure you can actually get your hands on the components. It might not be the given that you're expecting. The cases for Raspberry Pi, and this is one of those things where the first party actually kind of sucks. Right? So these are first party Raspberry Pi cases. So when you get the Raspberry Pi, you just get this. Again, you don't even get a case or anything like that. What I will tell you is this is how I run my Raspberry Pis. I don't bother with cases or any of that kind of stuff because I don't have anybody trying to lick these things. I don't have kids in the house. Right? I don't have to worry about investors carrying what I have going on. They're generally safe. I am not a fire marshal. I'm not a fire marshal, but I feel safe with them just kind of sitting on the desk. Like literally, this one right here is just kind of sitting on a pile of wires, and you can't see it. So if you just have this, I'm not a fire marshal, but should be generally fine. This is how I run them. But if you want a case, Raspberry Pi does offer cases. So again, this is a Raspberry Pi 4 case, and this is a Raspberry Pi 5 case. Now, one of the things you'll notice about the Raspberry Pi 4 case is there is literally no ventilation. They don't even pretend. They don't even bother to put holes in the case. So not even passive ventilation. Like not even pretending to be passive ventilation. There's just no ventilation on this, which is probably fine for many applications. If you have a little FTP server, should be fine. If you have a lot of the stupid stuff that you're doing through Raspberry Pi, should be fine. But again, if you're getting the AI world, let's say OpenCV, so you can run OpenCV on a Raspberry Pi 4. I've done that in the past. The thing is, that starts jacking up the heat on your CPU. Remember, if the heat on your CPU gets above a certain level, it will start throttling, and then you'll get weird heating issues. So, you shove a Raspberry Pi 4 in a completely sealed case and you start running OpenCV on it, you might run into some quirks. One of the things I didn't put here, as I just realized, is when you buy the Raspberry Pi 4s, you don't necessarily get these heat sinks. So this is a heat sink here. Do I have another Raspberry Pi 4 in here? No, I have so many Raspberry Pis around. Anyways, this is a heat sink here. You don't necessarily get these heat sinks when you buy the Raspberry Pi 4, so that's another consideration depending on what you're doing with the Raspberry Pi 4, about whether you want heat sinks and fans and that type of deal. Now the Raspberry Pi 5, again, it's 3 times as fast, 3 times as powerful as the 4, and they give it barely adequate ventilation. So this is the Raspberry Pi 5 case. If you can barely notice, at the top of the case, that's actually a spacer, so that's a space for air. And then if we crack this open, you will see that there's a fan. So basically what you have in this thing is the bottom of it has holes, right, for ventilation. And then this has the fan, and then this goes on top of it. But one of the things I will just point out to you, I keep putting stuff down. Where do I keep putting stuff down? One of the things I will point out to you, am I losing my mind? Did I drop something? No, there it is. Anyways, all right, so this isn't the exact same form factor, but what I want you to think about with is ventilation. So here's the air vents. Here is essentially what the Raspberry Pi is going to look like when you shove this together. What do you think that airflow is going to be? Anyways, dog's vomit is what it's going to be. So that is why when you're going with cases, I would highly recommend, unless you're doing some very, very low power application, that you actually go with a third-party case. Third party makes much, much better, far superior cases. You literally could not be almost worse than it. These are literally about the worst you can make a case. It is bizarre how poorly these damn things are designed. Anyways, with the Raspberry Pi 4, you will see here that I do have these heat sinks. They're just little sticker things that you stick on. When you get the Raspberry Pi 5, if I can pick this thing up and stop everything. one of the things you'll see on it, I don't know if you will see on it, but anyways, see a silver thing on top? This is actually an active cooler. So again, I have this out of the case, it's just sitting there. This is an active cooler. So we got this big old heatsink here, it has a fan directly connected based essentially to the board, and this is probably the thing that you want for your Raspberry Pi 5. So it costs about $5 or $6 additional dollars. You basically put it on there, and then it will cool it properly for most of the applications that you're going to be dealing with. So yeah, so that's one of the weird things with the Raspberry Pi, is heat of all things. Heat is actually going to be a big issue for you. We started talking about displays. Again, there's all kinds of displays. So you can output. Again, you can output to a normal HDMI. So I don't know if this thing is still on. So we go to 2. There we go. So this is actually the Raspberry Pi. This is actually the Raspberry Pi 5. That's right there. Output into a 65-inch screen. And I don't know. YouTube can tell it's a decent quality. I don't know if you guys can tell it's a decent quality, but this is 4K. This is actually a very nice, decent quality 4K. So this is one of the things that you can do with displays. They also, again, as far as displays are concerned, again, third-party manufacturers. They have a lot of these kinds of displays out there. These are actually touchscreen. So you connect a USB connector to your Raspberry Pi, and then it acts as a touchscreen. So if you want to create a kiosk or that type of deal, you can do that. The one thing that I will warn you about, again, like with this has a form factor for a Raspberry Pi 4. So I can just take my Raspberry Pi 4 and I can actually just screw this whole thing onto this unit, and that is the unit. Put a little protection around it and away we go. Raspberry Pi 5, yeah, doesn't fit that way. So again, one of those things to be considering. And then again, as I showed you, what's cool with like real full-fledged screens is, again, this is a 480 screen. Basically, if I pull it out, see, basically I pull it out here. And what you can see is it's got the ribbon cable. So we have the display ribbon cable going from the Raspberry Pi 4 board into this particular screen, and that's the only connector you need. So that's a nice little solid device right there. Let's see here, cameras. Cameras are great. So you can get all kinds of cameras. Let me go get another camera. Oh, I need a better studio. Send me money so I can get a better studio. Anyways, I mean, the good thing about having a really small studio is I don't have to go very far. Anyways, so there's all kinds of cameras out there. So you want to connect a camera, basically just connect the camera in. The camera that I had before is here. So this is kind of like the standard Raspberry Pi 3 camera. That's about the size of it. This is what's called a wide angle camera. So this is cool. So this is a vehicle. So this is something called Dojo Derby. Literally built cars using a Raspberry Pi 4. Anyways, what's cool about this is it's wide angle. So like when you have this and you're remotely controlling a vehicle, you really do get tunnel vision. So like when you're trying to navigate, you know, in a very small world and you can only see like this, it's actually hard to navigate. Like you get a good picture. You get a good worthless picture. It's incredibly good quality, but not very useful. The nice part about like a wide angle lens is this thing gives you like, literally, it's damn near 180 degree perspective. It's ugly. Oh, it's ugly. You're not going to take pictures with it. But again, the weird part is having a 180 degree ugly real-time image coming in is actually better than having like a 60 degree high quality image coming in as far as a robot is concerned. So they got wide angle lenses, they've got night vision lenses, they've got cameras, they've got cameras where you can actually put on fixed lenses if you're trying to do things like security cameras and all that kind of stuff. One of the things that I'd recommend is Raspberry Pi actually creates their own cameras. They cost about $30. Last time I bought them from them, it cost $30 a piece. One of the things that I'll say is Arducam. Arducam is great. So Arducam, basically they make cameras for IoT devices, and they have just a, if I remember what screen I'm dealing with, they just have a crap ton of cameras for Pi. So for Pis, for Arduinos, for all kinds of different things. They have all kinds of different cameras for different situations. So I would highly recommend you take a look at Arducam. So like I say, the Raspberry Pi version of this camera, the official one, is like $30. The Arducam version of this camera is like $10. And I gotta say, horseshoes and hand grenades, it's about the same. Like if you really put them side by side, and you're gonna be Marquez Brownlee, and you're gonna be all like comparing the pixels, maybe the $30 one is better. I gotta say, it's just being a normal damn geek. I can't even tell the difference. It's not like, oh, I'm saving $20. I'm willing to give up a certain amount of quality to save $20. I can't really tell the damn difference. So I would take a look at Arducam if you're interested in cameras. They are great. Then we have hats. So when we talk about things that you can connect to your Raspberry Pi, we'll talk about modules in a minute. But basically, the next accessory is something called a hat. So in the Arduino world, if you know about Arduinos, there is something that are called shields, and shields connect essentially to the top of the Arduino and add different functionality, GPS, motor control, that kind of thing. In the Raspberry Pi world, that same kind of connector board is called a hat. So this is a hat from a company called Blues, really cool for IoT communication. And essentially what you do with this is you take this, and then you mumble to yourself, and like a Disney character does, come on, come on, come on, come on, come on. Oh, there we go. And then you slot it in. And that's why it's called a hat. It's like a hat. You put it on, and there you go. It's now connected. So the hats are generally used when you need a lot more connectivity to the Raspberry Pi board, and you can get that. The thing is with hats, just realize, again, if you've got cases or whatever else, as soon as you start shoving hats on, it's not going to fit in the case. The other thing is, again, these are GPIO pins. We'll talk a little bit more in a second. With hats, many of the hats require use of specific GPIO pins. So even though all of the GPIO pins are physically here, when you write your code, if you write code in such a way that you try to access a GPIO pin that the hat needs, quirks will come for you. So just whenever you do your research, it'll generally tell you what GPIO pins the hat is actually using. And so when you create your Python code, stay the hell away from those specific GPIO pins. Let's see here. Then we come down. I guess we'll talk about GPIO pins later. We'll talk about it a little bit later. So let's take a look at PiOS and installing PiOS. So basically, in order to install PiOS, you will go to Raspberry Pi, and you're going to install the Raspberry Pi imager. So you do not install Raspberry Pi like you normally do with a lot of operating systems, where you shove a disk in somewhere. Basically what you have is this imaging software, and this imaging software is what you will use to create an image on an SD card, and then from there do whatever it is that you're going to do. I do realize I downloaded the imager. I forgot to install it. So basically you download it, then it's going to say to do that. If you're on a Mac, then you're going to say replace, because it's probably a very old version I have on there. Okay, so then we're going to take a look. We go to applications. Where is my application? Raspberry Pi imager. So you're looking for the Raspberry Pi. You double click on that. You want to say open. There we go. Okay, so then we're going to get this. All right, we'll drag this. So this is what it looks like. So you're going to need your SD card. So now remember so it's a micro SD card. So with that is going to be all of your storage. That is going to be your hard drive. So you can use a 16 gig SD card, or micro SD card, again, if you do not expect to store very much on the thing. But again, they've got micro SD cards that go all the way up to a terabyte now, so which one you pick is up to you. One of the things to look at with the micro SD cards, though, is the speed, right? So whenever you're looking at storage, there's size and then there's speed. I would go with a very fast 32 or 64 gig micro SD card rather than a slow terabyte card. It's going to make your life a lot better. Again, my standard that I use around here are the 64 gig SD cards, and I don't know, I use SanDisk. Oh, this is a 256. Anyways, isn't that amazing? 256 gigs on that thing. Anyways, but I use SanDisk, whatever the hell ones they recommend that you use. Just buy faster. Again, if you're gonna spend money on your micro SD card. Anyways, so when you do this, you're gonna get 3 options. So the first is your Raspberry Pi device. What device are you going to be installing the operating system in? Pi 5, Pi 4, 0, blase blase. You get the point. Let me choose 5. So once you choose 5, you can then go to choose your operating system. So they're going to have the options for you here. Raspberry Pi OS 64-bit is what is recommended. They have a 32-bit version, and then they have a whole bunch of other stuff down here. Now for other general purpose OS, one of the interesting things is they actually have the Ubuntu version for you. So if you want to keep everything within one family operating system for you to be able to support, you can actually use Ubuntu here. Ubuntu does work on 4. So I had Ubuntu working perfectly on 4 like 4 years ago. They don't give you this option on 4, but you should be able to install Ubuntu on 4 if you want to. You can choose from Ubuntu server. So they got the desktop version, they got the server version, and they have their core version. So that's something to think about. Now, one of the things with these operating systems, right? So if they've got Raspberry Pi OS and they've got Ubuntu, why would you go with PiOS versus Ubuntu? And the main thing is all of the drivers and everything that are installed on PiOS by default. So PiOS is a fork of the Debian, right? No, it's a distro. Yeah, words. Okay. So PiOS is a distribution of the Debian fork, right? So there's major forks in the Linux world, right? There's the Red Hat world, there's a Red Hat fork, and basically there's Debian fork and some other forks out there. Anyways, Debian is a main fork. Ubuntu is a distribution of Debian. PiOS is a distribution of Debian. What makes PiOS different is that it has all of the functionality built directly in, already included with the operating system. So when you go to connect to GPIO pins, when you go to connect a camera, when you go to connect a display, all of that stuff should work relatively easily. Now you can make all that work with Ubuntu if you want to, but you know, that's going to be extra work. And so that's one of the things to consider. So if all you're doing with your Pi device is just running it essentially as a normal computer, you're not really worried about the pins or anything, Ubuntu is fine. Again, if you're using the other stuff, right, blah, blah. Anyway, so you go here, you click on that, and then you say what storage. I don't have a micro SD card plugged in. So anyways, it would show an SD card if I wanted to. I would click on the micro SD card, and then I'd go get a cup of coffee. This does take a minute. This does take a minute or 5 or 10. So, you know, go and do something else while it's doing its deal. But that's basically how you're going to install the operating system. Then once you do, you unplug it from this computer, and then you shove it into the port on the Raspberry Pi. So Raspberry Pi 5 or 4, Raspberry Pi 0, so on and so forth. Let's see here. So that's how you install it. So let's give you a little bit of a tour of the PiOS environment. So again, I've got my Pi 4 sitting here. There we go. So look, it's Pi. It's a GUI operating system. So again, whenever you're dealing with Linux, you can either have a GUI, graphical user interface environment, or you can have a command line environment. You know, this is easier to use, especially Pi 5. Pi 4s and Pi 5s have more than enough power to run GUIs, so it's easy to use. Basically, when we do this, let me just minimize. So I can just minimize that. I minimize that, and then you see this picture. So this guy, I guess when you see this is the latest image, latest desktop for when you're using it now. But anyways, you take a look at it, it looks very much like Linux. You have essentially the equivalent of the start button here, you have an internet browser here, you have a file explorer here, you have the command line here, you have the open tabs here. Over here is your information for your network and all that kind of stuff. So if you click on that, you get the options for connecting to VPN or connecting to wireless. When you see this, you get your Bluetooth, and when you see this, you get your sound. Right? Normal, pretty normal stuff. Again, this will give you terminal if you want terminal. This will give you your file explorer if you want file explorer. This will give you your internet. So when you install this, you can either install it with Firefox or with Chromium. I do think Chromium is better than Firefox, I do got to admit. But anyways, when you click on that, it'll open up whatever your default web browser is. Then we can come here to essentially the Start button. When you do this, they're going to give you some initial programming editors. So they give you Thonny and they give you Genie programming editor. I think Thonny you're supposed to use for Python. Anyways, you can just install VS Code. Use VS Code. In order to install VS Code, you actually have to go to Terminal. You do apt install code, and that will install VS Code for you. Anyways, and when you do, it's VS Code like you're used to. You have the internet, gives you the option for Chromium or Firefox. Sound gives you VLC. Graphics gives you an image viewer. Accessories, gives you all this kind of stuff. You can image other operating systems out of here. You get Task Manager, that type of thing. And then we can come to Preferences. Preferences, so they have add remove software. That's kind of slow. It is slow. I'm not going to do it now. But basically, if you just want to install software from a repository, that's what you do. Appearance settings, keyboard or mouse, main menu editor, all this kind of stuff here. Now, one of the things that you're going to need to take a look at, though, is Raspberry Pi configuration, right? Oops. Raspberry Pi configuration is going to be very important. So we come here, you open up Raspberry Pi configuration, your password, your host name is there. What you boot to, are you going to boot to a desktop or are you going to boot to the command line? Auto login, will you have it auto login or not? And what your default browser is. Right, so those are there. You can select displays, touch screen if found, but the big thing here is going to be interfaces. So when you start doing really fun things with Raspberry Pi, this is going to be what's going to trip you up. I don't know why this exists. This sucks. This has been here forever, and it still sucks. Basically, for connections, to be able to communicate with your Raspberry Pi, you actually have to enable them here. So if you want an SSH connection to the Raspberry Pi, you have to enable it here. VNC, so that's basically a remote desktop, you have to enable it here. So I2C, so I have the screen here, I'll show it to you later, but I2C is an electronics protocol, fabulous. It's amazing. Anyways, what you do is you connect a couple of cables, you connect it to the Raspberry Pi. It's actually an addressable scheme. Anyways, you're able to communicate with I2C devices that are connected to your Raspberry Pi. Yeah, for some reason you have to enable that here. You can write all of your code perfectly, you can have your modules working perfectly, and if you do not enable I2C, it's not gonna work. Look at the frustration in my face. Know the pain is real. Make sure you enable I2C or your life is going to be miserable. Serial port, whatever. Anyways, some of this additional stuff. So if you're doing anything where you're like connecting to the Pi and it's just not working, before you rewrite all of your code or do something stupid, do come here to interfaces and make sure it's enabled. What is there? There's performance. Performance and localization, yeah, that kind of stuff. Then beyond that, you come down here to preferences, and they have the screen configuration. So this is where you can, if you right-click, you can do the resolution, you can do the frequency, you can do the orientation, you can change all of that kind of stuff here. I will tell you, like I was showing people before the class really started, if you have this at 4K, so 4K on a 65-inch screen, things start to get really small on here. And so that is one of the things to consider. Even if you've got a really good quality screen, you might want to keep it at 1080p so everything's not tiny or whatever else. So yeah, that's really all there is to the operating system. A very simple GUI interface. And again, if you want all of your nice little command line stuff, you can come here and maybe do top or whatever. Right, you got all your stuff. So you can install Apache, you can install Nginx, you can install Bottle and have all of that kind of stuff running. So again, this is Debian. So most of the time when we're using Linux, we use Ubuntu just as a standardization practice. You're not going to run into a lot of difference. If you use Pi instead of Ubuntu, I don't think there's going to be a whole bunch of difference. I will tell you, if you run Ubuntu on a Pi, there will be some troubleshooting stuff that you'll have to work through. So, just one of those kind of things to consider. Let's see here. Oops, too many mices. Too many mices. Okay, so let's take a look at the GPIOs. So GPIO 0. One of the cool things that's built into the PiOS is a Python module called GPIO 0. So again, if you're running Ubuntu or something else on your Pi, the big thing is you're going to have to figure out how to install this damn thing onto it. If we go and take a look at it, basically what this does is this allows you to access the GPIO pins, right? So the GPIO pins, again, try not to break anything here. Anyways, the GPIO pins, again, are these pins up at the top. I do believe it's got 48 of them. Different pins do different things. So most of the pins you can use for communication. Some of the pins provide 5-volt power. Some of the pins act as grounds, and some of the pins provide 3.3-volt power. So do be careful how you connect the pins to your devices. You don't want to melt them or destroy them, but basically you connect things to these pins. All right, so if you take a look at this, basically when you're looking, it'll be the pins are this way, and this shows you what the pins are. So 5-volt ground, and then like there's some other stuff here to take a look at. So when you're using I2C, so I2C uses something called an SDA pin and an SCL pin. Whether you're doing Pi, whether you're doing Arduino, whatever else, they're just called SDA and SCL. So GPIO2 and GPIO3 are your SDA and your SCLs. You got 3.3 volt power supply here, you have ground here, you have 3.3 here, you have ground here, you have ground here, you have ground here, and you have ground here. And again, you've got some different things. When you're taking a look at the numbering scheme, so this is, I think I said, in my description I said, so Broadcom. Alright, so there's Broadcom numbering and board numbering. So important thing to keep in mind. So board numbering is the actual number of the pin. So by board numbering, pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, right? That's what we're talking about with board numbering. Then there's something called Broadcom. So Broadcom is the processor or whatever is on here. So there's called Broadcom numbering, and Broadcom numbering is basically how you identify these different pins normally when you're writing like Python scripts or whatever else. The reason is when you're writing something like a Python script, and the different boards, even though they look the same, the board numbering is always going to be the same. The Broadcom numbering on different Raspberry Pis might be different in relations, right? So GPIO 23 here goes to board pin 16. On a different board, GPIO pin 23 might connect to like board pin 23. And so when you're writing the code, if you say 23, then that's now going to be connecting to something else functionally. So anyways, so basically Broadcom numbering, board numbering, more or less focus on Broadcom numbering. So if you see in the code where it says pin 18 in the code, it means GPIO pin 18 for Broadcom, not 12. Right? This is 12 board, 18 Broadcom. 18 Broadcom is what you're going to care about. 19 Broadcom, 21 board. 19 Broadcom is kind of what you're going to be care about. If you go back and you look at older like tutorials or DIYs for Raspberry Pis, there used to be a better way of differentiating. You could say, I'm either using Broadcom or board numbering in the code, and then you'd have to use the appropriate number based off of either Broadcom or board. That all gets very confusing. Anyways, when you go, one of the cool things is with your particular GPIO pin, there's actually a command you can run on your Raspberry Pi. Control C. There we go. It's called pinout. Just PINOUT. And when you do that, this will actually show you what the pinout of your board is. And it'll also give you some additional information. So again, if you got like a whole pile of these and you throw it into a project and you're like, crap, what the hell am I dealing with? I don't know if you can see this, but it tells you it's a Raspberry Pi 5B version 1. It tells you it has 8 gigs of RAM. It tells you USB ports. And then when you come down here, again, if you're looking for the numbering, it shows you what all the numbering is for this particular board. So if you get confused, you don't have Google or whatever else, you can run the command pinout to get that. Oh, let's see here. So we go back, we take a look at GPIO 0. Oops. Okay, so we go to GPIO 0, and so basically this is the manual for how you use GPIO 0, and it's all, relatively simple. They've got recipes over here, so they've got the basics of installing it. They have basic recipes and advanced recipes. So again, anything that you're going to do, if you're connecting sensors, you're connecting outputs, that's going to basically be the same regardless of what project you're doing. The fancy stuff is going to be what you're doing in the back end with the Python code. So this gives you the basics. Like here, increase the size of this a little bit. So this will actually show you how to connect an LED. So I have this, we'll run this on the board in a minute. So from GPIO 0, import LED. From time, import sleep. So LED is going to equal the function LED for pin 17. So LED is going to be connected to GPIO pin 17. While true, a continuous loop. LED.on, so it's going to turn the LED on, it's going to sleep for a second, LED.off, it's going to turn the LED off, it's going to sleep for a second, and then it's going to loop. That's all it is. And again, that's how you can make an LED function. So again, if you're doing some kind of sensor value, again, imagine you're going out, you're trying to see if Google is accessible or Salesforce is accessible, right? So basically you go out, you'd use the get, you do the get, you read back the response value. Is it a 200 response value? So 200 is good. Is it a 400? Any other response value is bad. So basically what you could say is get, google.com, if response value equals 200, LED green on, LED red off, else, so you get any other value other than 200, LED green off, LED red on. And so that can be a very simple display for you, again, for something like testing, whether websites are up and running. They've got one for a button, so you can use a button. So you can actually connect buttons to this, so you can actually have a physical control instead of a full-fledged keyboard, that type of deal. If you go, again, they've got these recipes here, and in the recipes they've just got all kinds of stuff. Let's see here, talk about the pin numbering. Let's see, so LED, so they'll also give you the diagrams here so you get a better idea. I do believe these are 10K ohm resistors. So if you connect an LED directly to your board, you will burn out the LED. These are 10K ohm resistors. Always make sure you put a 10K ohm resistor between the positive, the VCC, and the LED, or you will melt the LED. But anyways, so it shows you a little diagram of how the LED works. LED with variable brightness, it gives you that example. Button, so we're going to play around with a button on it. Button controlled LED. Anyway, so they got like a lot of these little basic things, create a little, so you can play around with this. Then you've got the advanced, recipes. This gets a little more interesting with sensors. I do think they have sensors here, right? They have a multi-character display. So you start wiring stuff up a little bit more complicatedly. A whom's home indicator. Anyways, blue dot LED. Thought they had sensors. Input devices. Anyways, they've got a lot of stuff here. Input devices. And now it's not working. Now it's not working. Is the internet working? It's the internet's working. Okay. Okay, anyways. Of course, it's a live class. Therefore, the website has failed. Why has the website failed? I don't know. Weird. Anyways, that's the GPIO 0 documentation. Oh, it normally works better than that. When in doubt, use ChatGPT. Use ChatGPT. Now there's something called the I2C protocol. And basically what the I2C protocol does is it allows you to communicate with electronic devices. So with I2C, one of the important things to understand about I2C is it is an addressable protocol scheme. Right, kind of like TCP/IP, but not really. So with I2C, the standard I2C, you can get like 128 addresses. There's another version, there's like an extended version of I2C, gets you something like 400 addresses. So those are all addresses that one device can communicate with. So these may be sensors that are sending value to the Raspberry Pi. They may be things like screens pulling values from the Raspberry Pi. One of the big things to be thinking about though with these I2C devices is generally the addresses are hard coded into the device itself. So I think this is 0x27 is the address. Well, the thing is, not only is this 0x27, the other 10 of these that I own are 0x27. Right, so basically they get hardwired at the factory. So if you want to have multiple displays, multiple of these kinds of displays saying different things, you're going to have to find them that actually have different addresses. Sometimes when you buy them from the manufacturer, they'll allow you to change the address. I think this might actually allow you to resolder something to change the address. But they might allow you to change the address using pins or soldering or that type of deal. But that is going to be one of those things to consider with it. So it is addressable, but it's generally hard-coded. One of the issues too is when you do get these hard-coded, sometimes you don't know what the address is. It's like, oops, it has an address. What is the address? Who the hell knows? There's this cool tool called I2C Detect, and that will actually tell you what the I2C address is. So we go over here, take a look at the computer again. Let me see if I can I increase the size? No, that's not increasing the size. Crap, how do I increase the size? I don't know. Anyways, so clear. I have no idea if you're going to be able to see this. Probably won't. Anyway, it's called I2C Detect. I think it's 1. Yes. Enter. Oops. It was yes. Anyways. Can you see that? I don't know if you can see that. Just believe me. Believe me when there is an output here and it's showing you what the address is. So I have a screen. I have one of these screens. It comes up at 27. So the address of it is 0x27. And that's what the thing is. Again, we start looking at this and we take a look at the code. We can bring up VS Code. And bring up VS Code. And so this is what the Python code looks like for the screen. Basically, I have an LCD module that's installed onto this computer. So we import time, and then from LCD, we import LCD. We put in the LCD information. So the LCD, this is actually for 2 lines. The address is 0 by 27, true for the backlight. And then we simply print out onto the screen, hello world, and I'm going to be doing this at line 2. And so, when that script gets run, it's being run, let me see if I can pick it up. See if I can pick it up and nothing horrible is going to happen. Ooh, it's a little hot, it's a little warm. Anyways, so this is the LCD screen. And God knows if you can see anything on it. I swear. Anyway, maybe if I pop off the, there you go. Can you see the hello world now? I swear it says hello world. I think you can see hello world. Anyway, see how it says hello world? So now your display. from the Python script, you're putting a value in and you're printing it out onto this I2C screen. So again, that's the kind of cool thing. Like imagine if you want to create a NAS, right? Or you want to create any kind of like IoT networking device. One of the big problems is they grab DHCP addresses and you have no idea what the hell their DHCP address is. So imagine if you have this, it grabs the DHCP address and then it literally tells you on the screen. You write some code in order to pull the IP address and then you print it out on the screen. That's what you can do with that. Again, for the LED, what I was showing you before, this is the LED test, right? So close that. So again, from GPIO 0, import LED, sleep, go to 17, while true, make it blink. And again, so this is the code that is simply running on the Pi. I now have that running. And look. Can you see it blinking? There you go. See, it's the LED blinking. And again, the important thing to understand, really crappy code, but that code is driving that LED to blink. That's the impressive part there. And then again, like I said, you can just make this more and more and more and more complicated. Let's see here. Yeah, no. Okay, so then beyond that, so that's the I2C, basically gives you an idea of how that works. And then sensors and outputs. So again, with these GPIO pins, you're able to connect a lot of different sensors, and there's just a tremendous number of sensors out there. So again, this is a GPS unit. So this actually pulls in your GPS, your lat long information, and then you can do with it as you see fit. This is an ultrasonic distance sensor. So using ultrasonic sound waves, it detects how far the sensor is away from something, and then that's simply a number value that goes in. This is called a PIR sensor, a passive infrared sensor. So basically just a motion sensor, like all the motion sensors you see. So that's a motion sensor that you could connect. This is a different, this is an LED distance sensor. So basically it shines out an LED light, and then when it detects a reflection, that's when it goes off. So that's good for like close things. This is a temperature and humidity sensor. So again, temperature and humidity and that type of deal. And yeah, that's all the sensors that I've got here. So basically all of these different types of sensors, everything from your GPS location to the temperature, to your distance away from something, to triggering when a motion is detected, all of that you can plug into your Raspberry Pi. You can then have Python process and do whatever it does based off of, you know, the events that get triggered. Yeah, and so I will get to you in one second, David, because we're basically at the end of the class. So that's basically the class. That's what the Raspberry Pi is. Blase, blase, blase. The final warning, the warning that it will warn you as a warning, is these are real computers. You are running Linux. You are running Debian Linux on them, which means it has all of the vulnerabilities and everything else that a normal computer would. So one of the things that you want to be very careful about is when you deploy these out in the real world, how are you going to deal with things like patch management? How are you going to deal with things like maintenance? Right? So again, if you have this, this is a full-fledged computer. You put 1,000 of these into your environment. How the hell are you going to maintain them? When you find out that some open source component has had a vulnerability for the past decade, because this happens every once in a while, what are you going to do with your 1,000 little Raspberry Pi devices that are out there? Again, that is one of the benefits of Arduino. This is not a full-fledged computer, so the threat that it has, there's less of a plane of attack against these types of things than there are with this. So anyways, that's it. Oops. Did he leave? David. I thought you had a question, David. Oh, David. What's up, David?
So I'm sure there's some like hats and stuff that you couldn't switch, but I have an Arduino starter kit with like that motion sensor.
Yep.
Can I use the motion sensor on my Raspberry Pi or?
Yeah. So okay. So these are considered These are modules. This is a hat. So in Arduino, they have versions of these called shields. So most likely you can't use a shield on a Pi. You should be able to use any of your modules. So if you have basically if you have this, you should be able to use this on your Pi.
Cool, thanks.
Yep. Yeah, that's the fun stuff with this. Again, really what you need to do is you just need to set an additional $100 aside. So that when you find out when you need to buy new crap, you'll buy the stuff you find out. Yep. Cool. Okay, let's see. Mute you. Doc Foley, what's up?
Hi, this is Jacques. Sorry. So I just got home, and I had a question. I saw a paper years ago about. Again, I don't know if you could use it now with the recent Raspberry Pis, but can you turn a Raspberry Pi into a server? The paper I saw a long time ago that I want to try is that how you could turn a group of Raspberry Pis to do microservices like a server. So with the newer Raspberry Pis, can you theoretically use it as a server?
So Jock, you've been around for a while, so I get to fuck with you. So you've been to the Linux class. So if this is a Linux OS, what do you think the answer is? Oh, Jock. Oh, yeah, I'm muted. Yep. What do you think the answer is?
So I know we use Linux and you caught me off guard. Because I'm rushing and I was trying to find this paper. Okay, I'm just gonna look stupid. Yes,
exactly. When you're dealing with Linux, because remember, in the Microsoft world, they're trying to sell everything. So when they give you a client operating system, they purposely kneecap it because the client operating system costs $100 and the server costs $600. So they purposely kneecap the client operating system so you can't really run it as a server. In the Linux world, they don't play those stupid ass games. So any Linux system, by and large, can be either a server or a desktop system. It's literally just what you install and what you configure. So yeah, these can, and that's why I say that's what's so powerful about these screens, is you can make this a full-fledged server, again, like a NAS file server, web server, whatever it is. And like I said, one of the nice parts is when you plug it into your network, you can find out what the hell a DHCP address is. Because a lot of times that's the only information you care about. You don't need a screen. I just need to know what the hell the IP address is.
Okay, nice. Yeah. Second question. So you're saying that we can use Raspberry Pis and we can use the Raspberry Pi operating system, or we can use Linux. For the frameworks you showed us, does it really make a difference which way we choose? Like if we use a bottle or anything like that? Because that's what you're showing us this, so I'm not familiar with. Will they both run on both Pi and Ubuntu?
Yeah.
When we use those frameworks?
Oops, no, wrong one. Yeah, because remember, so as I said, so Debian is a fork of Linux. You have the Red Hat fork and you have the Debian fork, maybe a couple of others. Ubuntu is a distribution of Debian. Raspberry Pi, PiOS is also a distribution of Debian. So their core, they're 99.99% the same. It's just, again, for the GUI, if you install Ubuntu, you'll get the Ubuntu GNOME GUI, and instead here you're getting their GUI. But here you'll be getting the Raspberry Pi, again, all that additional functionality for the I2C stuff is built into it. So basically, this is more or less, from your standpoint, this is the same as at the command line. When you go to when you're using the command line, basically, it's going to be the same as Ubuntu.
Gotcha.
So again, so you can install Bottle, you can install Nginx. Again, we did the class on how to deploy a Bottle web app. All of that should work almost exactly the same on here. Yep.
All right, thank you.
Yep. Okay, Christopher, what's up?
I just had a question.
Yep.
Would the keyboard be the same thing that a new Raspberry Pi keyboard? Like, is it better to get a board, or can you get that keyboard?
Oh, the keyboard thing. Yeah, so what he's talking about is, again, it's all form factor and what you're trying to accomplish in life. So, I just want to show everybody at home what you're talking about. Pi keyboard. It's like the Pi 500, I think it's called. Yeah, it's not that. Official 400 kit. Accept the cookies. Yeah, so basically, the cool thing with this is, I guess it's a 400, I thought it was a 500. Anyways, so it is a Raspberry Pi that's literally built into the keyboard. So it's here, there's a little SD card somewhere around it. It does have slightly different tech specs. You do get access to the GPIO pins in the back. So again, if you want to do this for testing purposes, make LEDs blink, it gives you some other connections too that can be rather nice. But what is it? Quad core, so it's 1.8 gigahertz instead of the 2.4 on the 5. It's only 4 gigs of RAM, depends on what the hell you're doing, whether or not that matters. So it's got some other stuff there. So this should be better than a 4, worse than a 5. And really, it just comes down to form factor. So this is all built in. So it's, to be clear, there's not a 4 or 5 or 0 inside where you can pop this thing open and rip it out. This is its own computer, and so if you buy this, you buy the. You're not going to be putting that thing most likely onto a robot car, but you also may not care. Yep.
Well, thank you.
Yep. No problem. Cool. So, any more questions? Jacques, what's up? What's up, Jacques? Ask to unmute. Okay. Yep, I did. Oh, there you go. Okay, yep.
Can you hear me? Yeah.
Yep.
So I was trying to learn Raspberry Pi in Ubuntu, but I got frustrated and stopped. I do have an original Raspberry Pi. I think I have a 2 whatever. Would you recommend just practicing? Because I'm guessing the software has been improved a lot. Work on that Raspberry Pi 2 first and try to get familiar with the software and upload it to that, and then try to buy, the newer version for $60. I know it's still not super expensive, but make sure I don't burn anything out. Download the software on an older Raspberry Pi, practice it, then get a new one, or just go ahead and just get the new one, just get the ball rolling.
Yeah, I mean, it's hard. I'm talking to people all over the world, so it's I don't know, and I don't want to presume what your budget is. What I would say is, if your budget allows, I just buy the 5 and be done with it. Because again, just for performance, when you start doing anything more complicated than making LEDs blink, it's only got so many resources on it. It's pretty damn hard to burn these things out, unless you do something kind of goofy. Be careful again with the pins. Right? Make sure you don't connect a 5-volt power out into a GPIO in. That might do something stupid. But you really have to not be paying attention to really fuck these things up. So I wouldn't. Again, if $60 means the world to you, don't do it. But yeah.
Okay. So last question. I'm right now going over old projects and actually writing out the code.
Yep.
Right now I'm going over our OpenCV, the code.
Yep.
That will only probably run on a 4 or a 5, correct?
Yeah. So these guys, I don't know how long you followed me for, but 2 years ago when I was really working on the Dojo Derby things, I actually had these. I used Louis Rossman's logo, and I could have this auto track and try to attack the logo. So again, it's not great. I mean, it is a potato, but yeah, you can run OpenCV. You can run OpenCV on video on a 4. It'll work much better on a 5. Again, when you start talking about OpenCV, there does become the question of what are you actually doing. I mean, it'll probably be slow as hell, but you might be able to run OpenCV on a 0 if you were only doing still images. So let's say you had this thing take a picture every minute, and then you wanted to detect if a face was in that picture. So it's not real. It's video has to be fast. So if you've got a minute or you've got 30 seconds, it has time to process off of. I don't know. OpenCV might to a degree work on this, but yeah.
Okay. All right.
Yep.
That helps me a lot. All right. Thank you.
Yeah. And that's gonna be the thing too. Like I say with you guys, like the whole testing. My argument for anything that you're going to deploy into the field, when you start building it, try to use the best hardware you can get your hands on, just so you don't want to be troubleshooting problems just because you got crap hardware, right? You know, you're like, oh, is it my code not working? Is it the framework not working? Or am I just using a potato? Like, you don't want to run into that while you're building and testing. Once you've built, once you've tested, once you've validated that the product, that the project works with that higher level, then what you start doing is then you start stepping down to basically worse and worse hardware to see what the performance is. And once you know it's working well, like once you have a project that works, it's easier to prune it down to something that works better on crappy hardware. Like if you start trying to build something on crappy hardware, you don't necessarily, like, is it failing because you're bad at coding or is it failing because you're on crappy hardware? Whereas if you got it working and then you try to put it on worse and worse and worse hardware and then you prune it, you might find out for this particular project it actually works well enough on this. So one of those things to be thinking about when you design. Why is Sean here? It's always funny when people come in like an hour and 40 minutes into the class. Hey, Sean, great for coming. Good news is you're not going to fail this class. Bad news is we don't have any grades. Anyways, Rich, what's up?
Hi, thanks for doing this. I just have a quick question. For someone that is like completely new to this, where would you say is the best way to like get ideas on what you can build and like sort of to get your hands dirty and just to learn more about this, generally speaking? What's the best path towards starting in terms of just what are the possibilities that you can? I mean, there are a ton of things just from what you've shared. There are a ton of things that you can build, but where do you start from, basically?
Really is, you buy one, I say you buy a 5 or a 4 or whatever, and get that set up. So make sure you understand the OS, make sure you understand how to communicate with a GPIO pin, and like get some LEDs in those 10K resistors. Those cost a couple of bucks. And then from there, honestly, just do a Google search. I mean, it is amazing how many like Pi projects, so like best Pi projects. Like people just document the hell out of different projects. I don't know. So best Pi projects, 10 projects, and then some to be thankful for. And again, you can literally just Google, and there will be different types of projects. So that's basically what I would say. Like think about what it is that you're interested in. Like again, I like GPS, right? So GPS Pi project. Anyway, so I spell. So build your own GPS tracking system with a Raspberry Pi Zero. So Instructables is a great site. So set up your own GPS tracking server on a Raspberry Pi, and then you can actually just go through and you can read all the information and get a better idea how all this kind of stuff works. So Instructable is a good site. And again, like I say, just kind of Google. And that's going to be one of the things too to be looking at is like what kind of hardware they're telling you to buy. Because again, LEDs cost a penny, they don't matter, but again, GPS units cost like $30. So if you start taking a look at these and you start seeing like what hardware different projects are requiring, that might also help you find like the one module that's going to work on multiple different of these projects, so that you can work on different ones when you spend a couple of bucks on a module. So yeah, basically just Google, like get an idea in your head, like kind of what you're interested in, and then just kind of Google search. Cool. On connectivity, can you find the Pi over the internet, remote access? How easily can this be done? By Sean. Yeah, I mean, it's a computer. If you know how to make your computer found on the internet, it's easy. If you don't know how to do it, it's hard. Yeah. It's a full-fledged computer, right? So if you have a server set up, so if you have a VNC, so VNC is remote desktop, kind of in the Linux world, you could have port forwarding, right? So if you have an externally, if you can get to your external IP address, you could forward whatever the hell the VNC port is to your little device, internal to your network. So that would allow it to be accessible from the outside world. There's a lot of like remote connectivity software nowadays that you can install like an agent onto your computer and then be able to access it from the outside world. So yeah, like when you look at VNC, when you look at SSH, when you look at Apache, when you look at Nginx, when you look at any of that kind of stuff, this is a full-fledged computer with TCP ports. So basically, if you understand how to get an external client to connect to an internal TCP port, you're good to go. If you don't, we got classes. Raspberry Pi OS has a Raspberry Pi connection app that makes it super easy. Oh, I have heard of that. I have not played with that yet. So you might want to play with that. Let's see here. Any more questions? It is a Friday. Friday. Any more questions? All right. Oh, one more question. Christopher. What's up, Chris?
You can connect a keyboard to another Raspberry Pi and program that, right?
What's that?
You can connect I guess you can connect another Raspberry Pi to another Raspberry Pi and program it. Like, take the keyboard, the 400 keyboard, and then program another Raspberry Pi, right?
Oh. Well, you'd have to be able to show this SD. So you mean like image the operating system?
No, not image the operating system. Let's say like I want to program the robot to go around the house, right?
Yeah.
One that you showed. But instead of putting a Raspberry Pi on it, you have to put a Raspberry Pi on it, I guess.
Yeah.
But you take the keyboard, that 500 keyboard that they sell, and then you could program that on the other Raspberry Pi.
Well, the thing to understand how this works is, again, because everybody gets confused about this. They're just computers, right? So this file here, so let's imagine this file actually runs a robot instead of an LED, right? This is just literally a script that's sitting in my home directory.
Okay.
So basically, so yes, but I think you're missing the point. So you can sit at the keyboard and you can write a Python script and you can upload it to your robot. So yes, you can program your robot from your keyboard, but I don't think it's working the way you think it's working.
Okay.
Yeah, so basically, like, it would just be like, imagine if I sat down on my Mac and I created a script and then I simply moved the script from my Mac to this Raspberry Pi, then yes, I'm programming the Raspberry Pi with the Mac, but you know what I'm saying? Yeah.
So it's better to just program it from the actual Pi and then let it do its thing?
Well, no, it's better. I would say it's better to program it from an M2 Mac. Honestly, it's better to write the code in whatever is most comfortable for you to write code, and then just ship it. Because like if I'm on my Mac, I have my normal browsers, I have my files, I have all my stuff there. So like with the keyboard is good. Like if it's a lab environment, like for your kids, and you're worried about them breaking crap. Again, I'd rather have them break a $70 computer than a MacBook, right? So again, like the keyboard is good for what it is, but it's gotta be a relatively cheap keyboard with a relatively crappy computer. And so if you're already gonna be building robots anyway, I would say just buy the 5 board or the 4 board and program for it on whatever you're on right now, frankly. Yeah.
Thank you.
Yeah. But yeah, that's a big thing with technology, though. Like, and again, I'm never trying to be like too smart. Like, I gotta be an instructor, so I gotta smack you guys with a koosh ball a little bit. But I'm not trying to be too harsh when I respond to these things, because that's one of the big problems we get to in technology. Is it's not that these things are complicated, is that many times we're looking at the problem from the wrong direction. You think a technology works in a certain way, so you're trying to interact with it in the way that you think it works. You're failing miserably because that's not how it works, and then you give up, right? And so that's where it's like a lot of this is it's really it's you full, like having a full perspective of how the technology actually works, so that you can then go and again solve the problems. Again, like I say with this. So again with Arduino versus Pi. Arduino, Pi. See the Arduino. What happens is you open the Arduino IDE on your computer. You write out all the code on your computer, and then you upload it. You actually connect this to your computer, and you upload the code to this, and away it goes. Again, like I say, this is a full-fledged computer. So you can put an FTP client on it, VSFTPD. You can do an FTP client. You could simply use Google. You could use Gmail. Right? You could type up all your code on your Mac, and then you could email it to yourself. And then you could open up a Gmail on this and then download the code from Gmail. That might be the easiest way to do it, right? So again, this is a computer, and this is just simply a computer that's running Python. That is literally the long and the short of it. So there you go. Let's see here. How well does Pi work as an ad blocker? I've seen a couple of tutorials on how to turn one into a Pi hole. Can you just leave it running 24/7 with no issues, overheating, etc.? Yeah, Pi holes are great. So Pi holes, basically they use DNS to block ads. So whenever you have an ad, DNS has to go out, resolve to the server where the ad is located. And so basically what the Pi hole does is when it gets a domain name from a marketing company, essentially instead of resolving to that server, it just fails it out. Pi holes work great. I mean, they're pretty good. The only thing with the Pi hole, again, you got to make sure you understand what you're doing. I get a little worried again with my wife in the house with the Pi hole. Pi holes can be dangerous in the wrong hands, right? Because again, it's syncing DNS requests, so it's not necessarily obvious when it's screwing something up. Like for some reason, like the wrong domain name gets put into their blacklist or whatever. Again, if I know what's supposed to happen and it's failing, I can go and troubleshoot. I'm like, oh, maybe it's the Pi hole. Like if my wife's computer is failing for some reason, like she might not even ask me what's going on. And so that's one thing. Like with Pi holes are great. No problems with them. You just gotta, again, it's your environment. Every piece of functionality you add to a system is also a vulnerability or a problem. Just kind of keep that in mind. No issues. I did have a Pi hole running. So again, with 4, that's actually, oh yeah, there you go. See, this used to be my Pi hole. It used to be my Pi hole. So I had this running like 24/7 for like a year until I just turned it off because I didn't care anymore. Yeah, that actually worked. In their case, that actually worked fine. 0 issues with it. So yeah, Pi hole should be fine. You can even run Pi holes on zeros. You can even run Pi holes on zeros. Because again, again, you think about the resource consumption, DNS is very low resource consumption. So you should even be able to run it on a 0. Let's see here. Dave. Thanks so much for the primer, Eli. Very informative. What is the most practical use you have put a Pi to, and what is your proudest Pi project that works reliably? Yeah, again, for me, Pi's, a lot of this stuff came after my consulting days. So again, I stopped doing like business work a while ago. Anyways, so Pi's came after that. So I haven't deployed Pi's. Again, I've done the Pi hole. I've built my little robots. I prove the point that they work. That's it. Again, I'm doing education. I'm doing education videos for a while now. So yeah, I have not deployed any amazing Pi projects. What am I most proud of with my Pis? My Louis Rossmann tracking robot. I used OpenCV. Again, OpenCV, automatic tracking of Louis Rossmann's logo. This little guy would keep going after Louis Rossmann until his poor little battery died. So I thought that was an interesting thing. So yeah, I mean, that's one of the things to think about too, is like when you think about like Pis and all that, because we got like a lot of IoT stuff in the house now. And again, are you going to build it? Remember, anything that you build, you have to support. Anything you build, you have to validate. So I got to say, swiping the credit card and paying somebody else $30 for a device that's already been validated, it's kind of a nice thing. That's one of the things to consider. And that's with like this. What I find interesting, especially for any of you folks out there that are still looking for tech jobs, again, it's that idea of sysadmin work, of sysadmin into the IoT sphere, right? So again, wiping and reloading computers isn't worth that much anymore. But again, if you can go to a company and you go, look, we're going to put 100 of these things in your environment to solve whatever problems that you're having, that's the kind of thing that becomes interesting. So anyways, those are my thoughts. Quick question. Eli, if you were to build a live GPS tracker for a car or an asset, how would you approach it? This. I don't know, would I use this? I'll probably use this. Okay, so Pi, say your compute. I've been talking about that. GPS, this pulls your GPS location. The next thing you need is you need the connectivity from your vehicle to you. So this is called Blue. This is a device from Blues, B-L-U-E-S, and they do IoT communication. So on Arduino, it sucks donkey balls. With Python on a Raspberry Pi, it's fabulous. So anyways, you plug this thing in, you install their module, and basically it communicates with JSON. The only weird thing is, like, it only has one format. You have to say everything in a JSON. But anyways, as long as you understand JSON. So this literally will send from anywhere in the world. So they have versions of these that are local. They have versions of these that are global. They actually have versions of these that are satellite. It can actually communicate with a satellite at right now. You can buy it right now. But anyways, so what you do is you have your Pi tracking the GPS information, and then periodically, once a minute, once every 5 minutes, once every 10 seconds, whatever else, it would send a communication up to Blue's servers that would contain the information that you care about. Here are the last coordinates I was at. They're at, again, with GPS, you get elevation, you get speed. It actually determines the speed you're currently going at. So you can do speed and long and elevation, a couple of other things. So you could send that out with this. That then goes up to Blue servers. Blue servers does something called a webhook, where it then sends to your server based off of whatever URL that you have. It'll send to your server, and then your server processes it. So I would probably say that. The thing that I like about these with Blues is, at least when I got this, probably about the same now, is you spent, this was the developer kit, right? So the developer kit was like $70. Anyways, you spend somewhere between $50 to $70 for one of these things. But it comes with 500 megs of data that won't expire for 10 years. And again, 500 megs of data in the modern world, you're like, what the hell? But you're sending JSON. You're sending JSON. You don't need much data for JSON. So unless you're hammering the hell. And so it's two-way communication. So you can send to this. You can send from it, and you can receive to it. So you can do that type of thing. You get the 500 megs once you buy it. You can also add more. You can add more to this thing. So if you run through the 500 megs, it's like $10 per 500 megs, right? So that's probably how I'd look at it. I would look at Blues. Blues, if you haven't taken a look at Blues, Blues is cool. Blues is cool. Arduino is crap. Arduino is crap. But Blues is cool. IoT. They're IoT modems. Get started with IoT. Turnkey IoT from blah, blah, blah. Develop in days, pilot in weeks, scale in months. Which is, yeah, it's basically true. Simple, blah, blah, blah. So this is the note card. This is the actual card that's used. They got the products. So note cards. Streamlined satellite connectivity for only $49. Star Note for Skylo for $49. The future of satellite IoT is here. The latest monumental breakthrough. Star Note, cost effective. Blah, blah, blah. So anyways, yeah, you can even do satellite. So I would take a look at Blues. And then if you take a look at Blues, tell them I sent you. And maybe they'll send me some money. And yeah, okay. Any more questions? Any more questions? Okay. If there are no more questions, again, I'll remind everybody. Perfect. Again, Silicon Dojo. If you have not been to silicondojo.com, start going to silicondojo.com. This is going to start being the hub of everything. Again, Wix offers a lot. If you're running a business, you might want to take a look at Wix. They've got a lot of stuff going on in the back end. So we have the membership, we have the forum, we have the schedule here. I'm going to start doing one-on-one. So basically we're going to start doing office hours soonish. I don't know. Got to set it up. I got to decide when I have time to do it. But basically, everything is going to go through here. What's really nice about this, especially from an educational standpoint, is they actually have a back-end CRM solution, customer relationship management solution. So one of the things that it does is like when you RSVP for a class, it'll track that. If you go through our program, so I'm currently working on these self-paced programs, so you can just follow through. It'll actually track your progress through there. When you do a forum post, it'll track that. But what's nice about that is I can also add additional information. I can add notes and that type of thing. And so when we do like a one-on-one meeting, I'm not frickin' walking in blind. Again, I did like 400 or 500 Skype meetings, and it always sucked because I always walked in blind. I had no idea who the hell I was talking to. And the nice part about this is if you start using this, then I start to get an idea of what the hell you're doing. And then if we have a one-on-one session, I'm walking into it having a vague idea of like what the hell's going on. So anyways, we got SiliconDojo.com. I would highly recommend you sign up because that is going to be the center of everything we do. Again, the other thing too is cool with this is they have live streaming components. I didn't know they had live streaming. You can actually live stream through Wix. They have video. They have all kinds of cool stuff. So anyways, if you have not signed up on Silicon Dojo, I would recommend it. And yeah, that is all I got. So no more questions. When is your next class? Yeah, I don't know why. I don't know why it hasn't shown up on Meetup, or it hasn't been announced. So the class I was supposed to teach on, Wednesday, so bottle templates, we had a windstorm that day, power was going up and down all day, so I canceled it. So we're going to have that class next Wednesday. So a few days from now, I guess. So that'll be the next class. And then beyond that, I have to figure out what's going on. Because it's December 13th. So again, we're in the US. Christmas is the 25th. We got all kinds of holidays and things going on. It's probably going to get a little sparse. It's probably going to get a little bit sparse from here till the end of the year. And then we'll get back in the normal routine. But it's not that I'm not working. To be clear, I'm still working. But I'll be focusing more on, again, creating these curriculums here. Because I think that's going to be great. Like that's like one of the problems we run into is, so I teach all this stuff, but like what happens if you miss the class? So if we have these curriculums, so if I have a Python introduction curriculum, if you don't understand how dictionaries work, you can just go to that curriculum, you can learn about dictionaries, and away you go. So we're going to have a Python curriculum, we're going to have the bottle curriculum, we're going to have the OpenCV curriculum, and the idea is like so many of these things that I'm teaching, we're then going to also have a self-paced component, and so you can follow along. So, we may not have a lot of live classes until the end of the year, but don't worry, I'll still be working. Yeah, that's all I got. Any more questions? Anything else? I gotta go get a run packet. Run. Gotta do a race tomorrow. I'm not gonna win. Cool. Okay, if that's it, cool. See y'all later.